Hello, everybody. I hope you're doing well. Today, we're going to explain the concept of chemical reaction and Lewis electron dot symbols. Let's start first with the chemical reaction. You already know it, and we're going to revise it briefly. The chemical reaction is breaking down bonds between the reactants molecules and formation of new bonds between products molecules. Here, for example, here we have two hydrogen atoms, and there is a single covalent bond between them. And the same here. So at first, we need to break down the bond, the single covalent bond between these two hydrogen atoms. And the same here. And also we need to break down the double covalent bond between these two oxygen atoms. And then we're going to form a new bonds between the products molecules here. Okay. So briefly, chemical reaction is breaking bonds between reactants molecules and formation of new bonds between products molecules. Easy. Do you think that um, noble gases, do they need to go through any chemical reaction? Sure not. Why? Helium. Helium, for example, has one s2. So the first energy level or s orbital is filled with two electrons. So it's satisfied. There is no need to lose or gain or share electrons. And the same for neon, argon, krypton, xenon, radon. All noble gases, they don't need to go through any chemical reaction. By the way, any other elements, they tend to reach the same electronic configuration of noble gases, of these noble gases. So other elements, they lose, they gain, they share electrons to reach this electronic configuration of the nearest noble gas. Okay? As you know, by sharing, by losing, by gaining electrons. Then we're going to talk about the Lewis electron dot symbols. Lewis explained a way to explain the number of valence electrons on the symbol of the element. So the valence electrons play an important role in the formation of bonds. So the scientist Lewis introduced a simple method to represent the valence electrons by using dots. What? So shall we replace the valence electrons by dots? Yeah. At first, what are the valence electrons? Valence electrons are electrons of the outermost energy level. For example, magnesium, Mg, it has 12 electrons, right? So let's make the electronic configuration. 1s2, 2s2, sure you know it, 2p6, and 3s2. So how many electrons here in the outermost energy level? Remember, outermost energy level. How many electrons in the outermost energy level? Two electrons. We have only two electrons. That's called valence electrons. So how to write it as Lewis electron dot symbol? Here is Lewis way. You're gonna write the symbol and two electrons. Okay, so shall you put these two electrons like this? No, that's wrong. So how can you replace these electrons by dots? You're gonna refer to these two electrons singly first, in a single electrons first, like this, one electron here and one electron here. Okay, so if you have if you put four electrons in all sides, then you can pair electrons. Let's get other example. Here, oxygen atom. Oxygen has 8 electrons. So its electronic configuration is 1s2, 2s2, 2p4, right? So how many valence electrons of oxygen atom? Here we have 2 electrons for 2s and 4 electrons for 2p, right? So how many valence electrons? 2 and 4, 6. We have 6 valence electrons. Let's draw them. Here we have oxygen, simple. As we said, singly first, you have to distribute these electrons singly first and then pair electrons. So 1 electron, 2, 3, 4, 5, 6. So again, distribute these electrons singly first and then pair these electrons. Here you have paired electrons and here you have paired electrons. And here this one is single and here this one is single. Okay. Do you know These paired electrons are called lone pair. Lone pair. This is called lone pair, and this is called lone pair. Okay, so here are other examples of the symbols of the other elements by Lewis Way. Okay, so here we have sodium has one valence electron, magnesium has two valence electrons, aluminum has three valence electrons, silicon has four, phosphorus has five, and as you see here, there is this one, it is called a lone pair. Here we have sulfur has two lone pairs, okay, as oxygen. Here chlorine has three lone pairs, and argon, sure, it has four lone pairs because it's noble gas. So this one is called, or this pair of electrons, this called lone pair. What about this? This is a chemical bond, right? And this one a chemical bond. And show you this one is a chemical bond, right? So let's here we have three bond electrons. Here we have bond electron and bond pair, and here bond pair, and here bond pair. Okay. And this one is called lone pair, and this one is called lone pair. So elements of the same group in the modern periodic table, they have the same number of lone pairs and the same number of bond pairs. Again, all elements of the same group, for example, here, like oxygen and sulfur, okay, they are in group 16 or 6A. So they have the same lone pairs, number of lone pairs, and number of bond pairs as here. When they react with hydrogen, for example, here we have lone pair, and here we have other lone pair. So we have two lone pairs. So oxygen here has two lone pairs and two bond pairs. What about sulfur here? The same, because they are in the same group. So lone pair and other lone pair. So here we have two lone pairs. And here we have one and two. So two bond pairs.